All right, welcome to a day in the life of the SweetLab at Portland State University. This is where we focus on using sensor systems that remotely relay data on the functionality and use of different environmental health technologies all over the world. We're currently working in 12 countries around the world where we put our sensors on things like stoves and water filters. This is a project with Del Agua and the Ministry of Health, EcoZoom, and Vestigard Franson to actually instrument our sensors on water filters, on cook stoves, inside a randomized control trial that the London School of Hygiene and Tropical Medicine has done. We put our sensors on cook stoves for monitoring indoor air quality. These have been in Haiti for 6 months with Mercy Corps. We can actually characterize different stoves using our own hood system where we test the different stoves and look at the air emissions from the air quality emissions from the stoves with our sensors. We also put the sensors on things like the Del Agua water test kit. Zach and Matt here are bringing these to India in the next couple months, where we put our sensors directly in the kit. There's a GPS unit on board and thermocouples, and they actually monitor when the kits are used and where they're used all over the world if the function is done properly. And the data comes straight back over the cell phone networks to the internet, where we're able to analyze it and develop algorithms that tell our partners how things are going. One application we're working on now is in Rwanda with Living Water International, and Zdenek and Faduma have been developing this technology over the past couple months to monitor the performance of things like this. It's an AfriDev pump. These pumps are installed by a bunch of different organizations. They cost between $5,000 and $15,000 to install. Living Water International has a few hundred in Rwanda. And one of the challenges is it does give access to communities to water, to groundwater, to safe drinking water, but there's a lot of moving parts and they can break sometimes, and implementers don't necessarily know that they're broken. And a lot of different groups will use things like SMSs for community members to let them know that there's a problem, or they'll send maintenance operators on circuits to go and look and see if there's a problem. But we want to see if we can further improve on that by having the pump actually tell a technician directly if there's a problem. So we have our sensor inside this pump. I'm going to show it to you in a minute. But in order to test our sensor, in order to analyze the data, in order to develop the algorithm that we use to tell us how much water is being used or if there's a problem with the pump, we have to pump a lot of water. And because we're engineers, we decided to automate that process. So I'm going to show you, right now there's on a timer. Every 30 minutes it's going to pump 5 gallons of water, but I'm just going to override it right now and have it show you what it's doing. So here's the automation system. It's actually pumping water. You can see water coming out of the pump. And if we look inside, you can see the pump head coming up and down. You can probably see our sensor inside there. And so we do this every half an hour for a whole bucket of water all day, all night long, so we gather enough data to inform the design of our algorithm. I'm going to stop it now because it's a little loud. And I'm going to take the pump apart in the same way technicians do in Rwanda. These pumps are designed to be pretty easily taken apart. You just need a simple tool. Going to unscrew the riser. Going to unscrew the pump handle. Going to hold up the riser here. Going to take out our aftermarket hydraulic add-on. Pull out the handle. Set it aside. I'm going to reach inside here. I'm going to pull out our sensor. So that's our sensor, fully contained in this box. No special tools, no holes in the pump. Inside this waterproof box is the actual board, the batteries, the antenna. So we run off of AA batteries. We can actually run off of a solar panel or rechargeable battery too. It's actually hardest to do it on the AA's, but we get about a year of battery life. That's our GPS chip. That's an accelerometer. That's the SIM card. So this is a T-Mobile SIM card right now. We can use any telecom operator around the world. The data is transmitted over the cell phone networks directly to the internet every night. And we can also remotely recalibrate our sensors. So from here in Portland or anywhere in the world, we can control these sensors and what they do. When the pump handle starts moving, the accelerometer triggers, and that actually turns on the pressure transducer. And the pressure transducer starts logging the water that is coming out of the pump. So with that information, we can see if people are pumping. There's the hole for the pressure transducer just on the bottom of the, just on the bottom of the sensor right there, it's hard to see, that little hole picks up the water pressure, and we can tell if people are trying to pump water, if water is actually coming out, how much water is coming out, and if there's a problem, like people are pumping but no water is coming out, we can alert the technicians. And the technicians get a text message directly from our online environment, and it tells them to come out and fix the pump. When they do that, they fill out online surveys on their smartphones that go directly to the internet, and we can compare their maintenance records with the surveys against what the sensors are telling us of the proper operation of the pump. And there we go. And that's what happens when you give an engineer a GoPro. This is the best we can come up with. So thanks for coming by.